This time we're going to consider the case where compounding is done several times in a year. Okay? The formula you may recall, no, from our first video, to compute for the total amount when compounding is done several times in a year, we have S equals P times 1 plus R over N raised to NT, where those variables are described as follows. Okay, so let's consider here another problem to illustrate this. Suppose an amount of 500 pesos is invested for 3 years at 10% interest that is compounded quarterly. Find the total amount. Okay, since we have the formula, we need only to identify the given. Okay, so your P is 500, your R is 10%, which is 0.10. Your T is 3 years, okay, and N is equal to 4. Now, why is N equals 4? Because when you say interest is compounded quarterly, it means how many quarters are there in a year? Of course, there are 4, no? So you are compounding the interest rate 4 times a year. So your N is equal to 4. Then let's plug this into the formula. P is 500 times 1 plus 0.10, which is your R, over 4, which is your N. Then raised to N times T, where N is 4 and T is 3. Okay. Again, we use our scientific calculator for this, and the value for the total amount at the end of 3 years is 672.44. Okay. Let's consider another example. This time we'll be considering other cases where compounding is done not only quarterly but also semi-annually, monthly, and weekly. How will this affect to the future value? Okay. So again, the amount of 10,000 is invested at 12% for 2 years. You find the future value, no, when the interest is compounded semi-annually, monthly, and weekly. We can actually do comparison, okay, of the amounts between this number of times of compounding. So let's start with letter A. Again, we have the formula, so we only need to plug in the given. Let's identify first the given. Your P is 10,000, okay? R is 0.12 and T is 2. Then for letter A, compounding is done semi-annually. So that means that your N is equal to 2. Semi-annually means 2 times, no, in a year. So substituting the given to the formula, we have this, right? S equals 10,000 for your P, 1 plus 0.12 for your R, and over N, which is 2, and 2 times 2, NT. Using our calculator, we obtain 12,624.77. Okay, now letter B. When compounding is done monthly. So if it is monthly, it means that you are compounding the interest 12 times, no, in a year. That's why your N is equal to 12. Again, we plug this into the formula. So you have this 10,000, 1 plus 0.12 over 12. This is your N times 12 raised to 12 times 2. Okay, using the calculator, we have 12,697.35 for our when compounding is done monthly. Third, compounding is done weekly. So how many times in a year is that? N is equal to 52 now. That's the number of times you're going to compound the interest rate. Why 52? Of course, because in 1 year you have 365 days. So you divide 365 by 7. 7 is the number of days in 1 week. So you have 52. Okay. So we use 52 for our N, then plug in again to the formula. You obtain 10,000 times 1 plus 0.12, which is your R, over 52, which is your N, raised to 52 times 2. Okay, the 2 here is number of years, right? Okay, so after 2 years, the amount is 12,708.98 pesos. Okay, that's the total amount. Okay, as you can see, if you do comparison, the greater the number of times compounding is done in a year, the greater the value actually, right? So this is for compounding in times per year. For our next problem, this time we're going to consider the case where we're asked to find for time. Okay, it's not here, the formula is not here, so what we're going to do is to derive the formula for t. Now t in the formula is an exponent. Okay, you remember from our previous video, we derived the formula for t, but this time we cannot use yeah, we will use the same property. Okay, so first what we do is to derive the formula for t from the given formula. Again, the objective is to isolate the t, but since t is an exponent, it's not easy to do that. Let's start first with removing p here. That means we divide both sides by p. Okay, so you have s over p equals 1 plus r over n raised to nt. And then recall again the property no, from natural logarithm. You have two numbers. Their ln's are equal. And then ln of x to the r equals r times ln of x. So since we want to isolate the t here, then we should convert this t to a non-exponent number. First step is to express both sides in terms of ln. Okay. So we have this, right? And then look at this expression on the right-hand side of the equation. It is of this form, no? So therefore, the exponent there, the nt, can be placed here on this side. That's why using the second property, you obtain this expression, right? Your nt now is here, okay? And then after that, we divide both sides by ln of 1 plus r over n, and n also. So t will be isolated, and we have ln of s over p over n times ln of 1 plus r over n. So we have the formula for p. That's why for this particular problem, we can solve this by using this formula. Okay, let's do that. What are the given? First, we have p equals 10,000, r is 0.12, and s equals 84,000. Okay, and your n is equal to 4. Why? Because the interest is compounded quarterly. Then let's plug this into the formula. Using that formula, we have ln of s over p. Now your s is 84,000 and your p is 10,000. That's why we have ln of 84,000 over 10,000. Then over n, right? So 4 times ln of 1 plus r, which is 0.12 over n, which is 4. Let's use our calculator for this, and we obtain 17.99998 for approximately 18 years. So it takes 18 years to reach the amount of 84,000 pesos, no, from 10,000, when the rate of interest is 12% compounded quarterly. Okay.